Finally, we're going to talk about the characteristics of an erosional coastline, and the picture that you see at the banner of all of these slides is in fact an erosional coastline. You can tell because the land is so high relative to the sea. Erosional coastlines are characterized by cliffs and headlands and lovely structures like arches, and we'll look at some of those in a minute. The Pacific coast of the U.S. is an erosional coastline along most of its boundary, but so are places like England's coast, and that's not a tectonic boundary. So they're not always at tectonic boundaries. So the kinds of things you see are cliffs, you see arches, you see caves, you see sea stacks, which are places where the arch is broken off and you just have a rock standing out by itself in the water. Some of these features are really quite spectacular. How do you form a cliff on the coast? Well, very much in the same way that a waterfall forms. You have the water, the ocean, coming in every day, and high tide sweeping up onto the beach and eroding the bottom of the cliff, and then very commonly it will cut into the cliff, and then ultimately the rock above will collapse, and you'll end up with the cliff receding away from the shore. The place where the tide washes every day is called a wave-cut platform, and sometimes that's just a beach, a nice flat beach, but sometimes there's rock down there too, as in this case, where the rock itself is being eroded. Can you see the old wave-cut platform in this picture? Sure, the church is sitting right on top of it. It's called a terrace, remember? Now, the other thing that you can see in this feature are rocky headlands, and those are places where the shoreline sticks out into the ocean, like right here, for example. Now, headlands are really interesting. Let's look at the physics of what's happening at a headland. So here is a diagram that shows the headland, and that's the yellow is the land part. And then out into the water, you see three different colors, the light green, the light purple, and the darker purple. And those lines in between those are topographic lines. Think about those as being depth lines, okay? So what happens as the wave approaches the headlands is that the wave front itself encounters different depths in different places. So let's look at let's look at the red line and the sides A and B of the red line. So here's the wave coming into shore. As it gets to the point where it's encountering the bottom, the A side of the line is actually hitting shallower water than the B side of the line at the same time. And so that's going to cause the A side of the line to slow down, and that will cause the wave front to bend towards A. So if you see that happening on each one of these lines, that means the wave front itself is going to bend towards the headland. And that's going to cause a lot of erosion at the headland and less erosion in the bay area here. And so as a consequence, you'll get nice little beaches building up in the bay, but the headland will slowly go away. And here's a picture showing the headland erosion through time. Ultimately, you will end up with the headland disappearing completely and a cliff with a long sandy beach in front of it. So shorelines will straighten over time. That's the takeaway message here.